Hi, I'm John, your Fix-It addict. It's a rainy, stormy, lightning night here in Florida, so I thought great opportunity to come in from the garage and work in the electronics workshop today. So I want to work on my new friend here, Fraidy Cat, the Halloween Cat by Gemmy Industries. He is an animatronic cat whose head articulates, eyes light up, jaw moves, there's a soundtrack, and the best feature of all, when he gets really mad, his back hunches up, goes really high. But his back isn't working. So I think there's something wrong with the transmission underneath the fur here. Oftentimes there's little nylon gears in there that get stripped, especially if it's picked up, because the base is pretty heavy. It's got to be able to take the weight of him, his head turning and stuff without moving around. So we're going to open up the fur and open up this transmission and have a look and see if we can fix it. I'd like to show you how to do it.
I'm the Halloween Cat with an alien life. I'm all day and night. No relief in sight. All I want is to be left alone. To wander on my own. But why do I always feel like I'm in the danger zone?
This is what we're going to need to fix Freddy Cat. You're definitely going to need a good strong headlight. You need a headlamp because it's going to be really hard to find the stitches. I know Gemmy Industries, they stitch the products really well, and it's hard to find the stitch and to open the fur up in the back here. You'll need some gears, good old Amazon gears. They have a gear and belt kit, and primarily a 10-tooth gear. These are always breaking on the motors. Razor blades, needle and thread, safety pin, some small hand tools, and some foam, because when we open them up we're going to need to build up some of the high points where the mechanical or bridging or structure goes up against the fur, because we don't want that sticking out, and we want to keep a smooth transition on his back. So I know he can't wait to get to the alley, so let's get started. Before you start searching for the stitch, get an idea of what, when, or how the fur is constructed. So if you go at the neck of these animatronics, oftentimes it's a separate piece. It's almost like a cap that pulls over a scarf. So if you roll the bottom up, you get a good idea. The head's something that moves all the time. There's wires in there, so they got to protect the wires and protect the fur from getting caught in all the animatronics in there. So you could see they've wrapped the metal head in a nylon, and you could see how the fur is on, it's a pretty slippery material it's mounted to. The edge of the fur has been kind of burnt to keep the fur from falling off. And you could see how they rolled the stitch right there to make that soft collar. You could just see the edge of the stitch. So we follow that pattern. We know that's what we're going to be running up against inside. You could see where the stitches start here and go around. Then his leg boots are separately stitched, but it would be nice if we could take that loose and just pull this down like a sock, but way too much trouble to re-sew all this, so let's move on. Now that we've located the stitches along the back, I've found that they go all the way up and down the back. They stop at the neck, and they're kind of glued there, which goes into stitches to the other parts, so we'll need to stop right where it's glued together. But we can go and we could part the fur and cut each stitch along the line, going as far as we can down the back. So I've already done so to reveal the inner workings. There's a sponge along the mechanical section inside so as not to create unusual looking protrusions along the fur. I've already taken and loosened the sponge. It's glued in place to expose. Here's the gearbox that controls the back arch. These clear covers are glued into place. We could get that loose. But I like what the company, the manufacturer, provides this reduction, and also a point that could allow for slippage if the unit is picked up, or if somebody tries to force the action on the unit. This will give, which is a real nice feature. Many times it will stop gears from getting stripped. You could see the back arch here goes to his back leg. There's a pin in here. Spin around. Here's the other side of the motor. There's a washer. The pivot point. There's another pivot point up here for the end of the arch at the top of his back. So what we're going to need to do is get this back piece out here, this rear pin, so we could bring these back legs back and to drop this piece down the transmission, which will allow the character to come together, which will allow us more fur to be exposed to get at the screw up here to release the transmission. The slip reduction system here is glued on, so you could take a hairdryer, heat it up gingerly, because the plastic they use will act like shrinking tubing. It'll actually start to shrink real quick on you if you overheat it. You just want to get it hot enough to massage the glue loose, where you could pry against the edges. Just softly heat it with a hairdryer, not a hot air gun. Once you heat it, you should be able to pry it off so you could get at the belt. They've used a star washer on here, which locks into a recess in the shaft. And you could see that there's two bars that come and hold it to the rear leg assembly. So we're going to need to pry that star washer off, but we don't want to aggravate or damage the assembly. So what we'll do is we'll put a razor blade in there to act as a pry base. Now with the razor blade inserted, you could see it kind of looks like a wagon wheel. There's stars that go around into a center point. Get a probe and start by prying one star back. Once you get that one star pried back, then you could move the washer up and it'll release. When you go to reassemble, you could just bend it back down and press it on. You can see where I bent one leg back on the washer. So now we could push the washer against that open leg and it should come right off. There it is. Now that the washer is out, the shaft should push right through, come out the other side. I said it should. Oftentimes it's going to not want to do what I want it to do, but there it is. Now you could pull the back leg back, drop the transmission down, bring the leg forward, that gives the ability to go way up here, so you could get at the other screw that's across here holding the transmission in place on his front legs. See, there's a bar, but there's also a screw. We'll get the screw out. There's the screw right there. Once he comes out, that's going to allow us to spread his shoulders so we could remove this shaft so we could drop the transmission out. On the other side of his back on the gearbox is this spring tension screw that needs to come out. Be sure to remove the belt before you proceed so we're not forcing the gears to turn while we're manipulating the gearbox. Now that the screw is removed from this, the arch of his back, you could pull these apart just enough to release this axle where it'll come out and you could pull the transmission out. Doing so, the transmission should now pull out. Now that the gearbox is free, you could remove these 4 screws and the cover of the gearbox will lift off, exposing the gears. Once the gearbox is opened up, you could closely inspect the teeth. Always go for the small ones. They're usually the ones that take the most strain. It's kind of like towing your car in first gear. If somebody tries to force the back or force it to move, all the pressure goes on these little gears. And if I look real close, I could see that this gear is split on the shaft, causing it to spin on the shaft under load. Here's an example of the split. You can see it's really hard to see, but there it is. I've got the razor blade in it. And it just spins free on the shaft, and when there's a load on it, it'll work sometimes, sometimes it won't. And it'll get worse as it heats up. So now we got to find that gear. So count the teeth on the gear. This one's got 10. And measure the width and the length and the shaft size. Mostly they're a common shaft size for the DC motors. And do some searching. MCM Electronics, Mauser Electronics, and oftentimes Amazon will even have these gears. I was able to obtain them in a lot of 10 from Amazon. Before you remove the gears from the transmission, it's good practice to take a picture of it first, so you know exactly where the gears go upon reassembly. So there's the broken gear, and it's part of the drive mechanism. So you can see where there's quite a bit of force applied to that gear, and it's why it broke. So this should pull straight off since it is already split. Once the gear is off, take your spindle, create a little base. You could set your transmission pulley assembly right on that base, and you could push the new gear on with your finger. Then follow your photo that you took earlier of the gears and then reinsert them in the transmission. When you're done, Buy some just clear silicone grease. You can get that at Home Depot, or you can order it on Amazon. It's kind of like Vaseline, but it doesn't have the petroleum derivatives that tend to foul up gears and get sticky with age. Silicone won't. And it won't interact with any of the plastics, the case, or anything. And it binds real good. It's not that affected by heat. Once your gears are repositioned, in position, reassemble the transmission. Reinstall the 4 screws. And for testing purposes, put the belt back on. And before we reinstall it, we're going to test the mechanism to make sure that it turns okay.
Like a Freddy Cat.
Perfect. Now remove the belt. Make sure your screws are in place and reinstall the gearbox. Before you complete the gearbox, make sure the lift assist spring is back over his shoulder shaft. It's easy to forget. Leave it out and you won't have enough lift support to assist with the back arch. Once the gearbox is in place, put the shoulder screw back in. I always add a bit of grease at any pinch point with springs and plastic to assist with the free movement, so it doesn't create jerky movement. It's a smoother transition during scene changes of the motor positioning. So apply a little grease, just a little bit, so it doesn't get into the fur. Here's the lacking star washer. So you could see where we lifted one of the 4 pins up to release the washer from the groove on the shaft. So press that back together flat again with pliers and reinsert that on his back hip shaft. Before you apply the star washer, look, there's 2 holes. The pin goes in the aft hole. If you're not sure, or if you forget which one it is, just look for the wear on where the washer was. And putting it in the aft hole gives it more arch. Be sure to remove any residual glue before you reattach the foam. If you have too much glue in place, it will create an unusual arch, additional lift on the foam and a wear point that'll drag the fur. Now that the glue is off, before you glue the foam on and do any more work, we'll need to make sure the belt is attached and put the cover back on. During this point of the reassembly, you don't want to be moving this gearbox a lot because it's really exaggerated. When you move the gears here, it's really putting a lot of weight on that, or a lot of pressure on that back gear that originally broke. So remember to keep him at rest or unarched while you're reassembling, and try not to do a lot of physical movement because it's really exaggerated on the gears with this reducer. So when you reattach the cover for the differential, the slip differential, use some hot melt glue on low temperature. Put it on the insides of the cap before you put the cap over. That way you could see where I glued it, where the fresh glue is here, so it doesn't get into the mechanism and yet it grips on the inside. Also along the top, it looks a little messy now, but it'll dry clear. Do the same thing on the top with the cap. Glue under the cap when you push it on. and then I put a line of hot melt glue over the top to make a smooth gliding place for the fur. Otherwise it'll catch and hang on sharp spots from the plastic cover. When you glue the foam back in place, you could see on the foam the outline where the glue was, where my thumb is, and along that line. And you could see that it matches right there. So you know where to put the foam. Glue it down with hot melt. You'll see it'll go down around the back tailbone mechanism and then offer some cushioning and create more of a natural look along the spine once it's in place. Just some touches of glue. Only apply glue to stationary parts. Don't apply any glue to the moving parts. The foam is just going to be glued along here, and it's just going to rest on this, and the fur will hold it in place. If you glue the foam to that, the foam's going to arch up here, and it'll get broken and could jam up the mechanism. Be very careful not to touch the fur with the hot melt glue, or when you're using hot melt glue, watch for trailing strands when you withdraw the glue from the subject. I would go as far as putting some towels around it, paper towels, or well, actually like a soft t-shirt type of towel, almost like a surgeon would put a towel around the surgical area so as nothing else gets touched by the glue. Gets on the fur and it's impossible to get off. So before we start sewing them up, I want to take some open cell foam and pull his hair against the grain. Doing that reveals the natural pattern of how the fur is attached to the background. This brings the fur up on its edge and reveals these intersections here that don't have fur, and that's the area we want to catch and sew. Between those points. Doing that, the stitch will be hidden when the fur is brushed back the other way. As you're sewing, keep brushing it back. Search for those patches of skin that don't have fur. The stitches are going to have to be pretty close together. See, they just disappear. But keep looking for those open spots. Again, the stitches have to be pretty close together because we've got the white background or the yellowish foam back there that'll be pretty obvious. Plus, we don't want any weak spots developing. It covers up really good. Just keep looking for those open patches of skin. I'd say keep the stitches maybe an 1/8 inch apart. No, maybe an 1/8. This is where it takes time. You have to kind of develop your own routine. But boy, it closes up real nice. And continue all the way back. Sewing is the most laborious part of the project. But you don't want to see a seam, of course, and it just takes the whole thing away. Keep looking for those tufts. Go between them, 1/8 inch, 1/4 inch, to kind of mix up the stitches so a pattern isn't created. And then you could take just a brush out. See how your stitches are working. Pretty good. Watch your distances as you proceed down so you don't end up with a pull in one direction or the other. It's got to be a consistent sewing pattern. So here we're starting to develop a high spot. I'm going to have to work out towards the end here. It would look really obvious if it had a pull either way. So this is not something you rush. You're at the very end of the project, and detail is everything. Well, here he is, complete. Freddy the Halloween Cat by Gemmy Products. Made in 1990, so he's in pretty good shape for his age. The furs come out really nice. The proper application of the foam inside the structural area maintains a natural rib cage here. You don't see any of the structure protruding through the fur. It's got a nice arch going here, tufting of the fur when he crouches, and he's doing pretty good. Let's give him a try. Really high arch. He's feeling better. He's ready for the alley. So it was an interesting project. A lot of time with the sewing and everything, but it's complete. It's really nice. So he should be good for many Halloweens to come. You don't get in trouble in the alley. Thanks for watching.